Hello, everyone. Welcome to your course, Deep Learning for Art, Aesthetics, and Creativity. Today, we have a very special speaker, Dr. Rebecca Fiebrink, and she is a great researcher in the area of art, especially music and AI. And the important thing is how she works on the human interaction side as well. So keeping human in the loop and making the musical dialogue between machine and human. But I should let her tell us more about her background and, of course, start the conversation and the talk.
Thank you. And thanks again for the invitation to come speak to everybody. So yeah, I'm Rebecca Fiebrink, and just a little bit about me and how I got into this area. I actually started working with machine learning and music as an undergraduate. In my undergraduate thesis, I was doing some work with a computational musicologist and got really interested in whether we could use machine learning to model the difficulty of playing a particular piece of music on a given instrument, and then maybe use information about that to maybe recommend studies for people or even generate new exercises for people. And this was around 2003. So this was way long time ago, before deep learning was really a thing on anybody's mind, except for maybe like Jeff Hinton. And from there, I did a master's in music technology, looking at how we can use machine learning to model genre and artist properties of audio and symbolic music data, and thought that I was going to continue working on that for a PhD. I did my PhD in computer science at Princeton and got really interested in in actually how artists and musicians might start to use the same kind of algorithms that I saw being used in early music recommendation algorithms, things that turned into Spotify and YouTube Music and so on. And so a lot of the talk that I'm going to give today actually grew out of my PhD work, and that shift from thinking about machine learning mainly as a computer scientist to thinking about machine learning as, what might creative people want to do with this? And because the roots of this work go way back to, the beginnings of my PhD in 2006 or so, there isn't a lot or even anything in this talk that's deep learning specific. However, I think most of what I'm going to be talking about here and the questions that I'm going to raise are relevant to the work with current deep learning algorithms. And hopefully we'll get you thinking about the creative utility of the kinds of things you're seeing in some new ways. So with that, I'm going to jump into my talk, which is titled How Machine Learning Can Benefit Human Creators. And I'm going to start this with a claim, which might be surprising or might be totally obvious to you. I don't know. This claim is that using machine learning to autonomously generate human-like creative output, whether that's music or art or something else, does not in itself support human creators. This isn't something that I've always seen questioned at communities like NeurIPS or the ICCC conference, where there's some really, great work on saying, how can we use GANs or transformers or whatever the latest approach is to try to make more and more realistic media content. Obviously, I think a lot of that work is really cool, but there's often an assumption that, if we do this better, then it's going to be more useful. And if you look at a lot of that work and put it in a creative context, it can kind of feel like we're reinventing Clippy with machine learning. So you may not be old enough to remember this, but this Microsoft Clippy, of course, is infamous for being annoying and not useful at all. And it's like Clippy popping up when you go into your music composition software and saying, "It looks like you're trying to compose a symphony. Would you like me to do it for you?" And of course, nobody really wants that. So in my research over the last decade or more, I've really been asking questions about, what does machine learning have to offer human creators? And specifically, how can machine learning support and extend people's creative practices? This began by working really exclusively in music, and since then it's expanded into other types of art practice in games and so on. So we could break this down a little bit and say, well, machine learning is really a set of tools for finding patterns, making predictions, and generating new data according to those patterns. We could say, when and why might these things be creatively useful for people? And furthermore, if we think something might be theoretically useful, how can we make it actually useful by enabling effective use by real people? And this doesn't just mean better algorithms. Often it means better tools, better software, better libraries, and often even better education. What do we teach creative practitioners about machine learning in order for them to be able to use ML tools effectively? All right. So when I began this stream of research in about 2008, I was really motivated by what I saw as a gap in the tool set available to creators who wanted to work with data or with machine learning. And this, at the time, lots of people were using tools like Python, I think, was just kind of beginning to be something that was useful. There were a lot of C++ libraries. MATLAB was really popular, but there wasn't really anything out there that was really nice to use in real time. There wasn't really anything out there that dealt well with media data, and especially sound. And what you had of creators using machine learning in music and art and other fields, but typically these were people who already had PhDs in computer science or electrical engineering. So it was hardly a representative sample of what people might want to do with these techniques. But of course, if you're somebody working with media in music or art or games, there are all sorts of really potentially interesting, useful sources of data everywhere around you, right? There's online repositories, there's things like Google Images, there's data that you might collect from sensors, whether that's from fitness trackers and smartphones, or more bespoke sensors, things like a Leap Motion or a Kinect, or cameras or microphones or biosensors. You might be interested in data from social media. You might think about all the things that a creator does when they're interacting with software to make music, or software to make art like Photoshop or Illustrator. All the sorts of things that a person does in that software could be considered a data stream that you might want to model or learn from, or generate again in a different context. So often these types of sensors or these types of programs have reasonably good APIs. Getting data from them is often pretty easy. However, interpreting and using this data is really hard, even if you're an expert programmer working in digital art or music. And of course, machine learning is, just like it is in industry, is potentially a really great tool for making sense of any of these diverse types of data. But as I said, when I started working in this area, there really weren't any tools that were useful for people who weren't already, using MATLAB in weird ways to try to make music or sound with it. Okay, and of course, a lot, I was working at that time at Princeton, and I was working with a lot of musicians and experimental composers there. And a lot of what I had done with music data in my master's previously, and a lot of what the creators around me might, have wanted to do looked usually like some kind of supervised learning problem. So it was often applying labels to data or making decisions in a computer about what to do, what the computer should do next based on data, perhaps about what a human was doing. So for instance, I had started out doing research in music by doing things like harmonic classification or labeling. And so maybe I want, in a creative context, I want a machine listening system that listens to the music that an acoustic musician is playing. And then based on what key that person is playing in, maybe they start a new piece of computer accompaniment or an autonomous compositional process in the computer. A lot of the composers I was working with were building new gestural musical instruments. They were doing things like using sensors to detect how somebody was moving with some kind of sensing apparatus. And then based on those motions, they were then having the instrument trigger new types of sounds. But of course, you can use the same kind of setup to build, say, gesturally controlled games where different motions that you make trigger different actions of an avatar, and so on. So of course, if you know anything about supervised learning or about machine learning, and I think most of you do at this point, this is a pretty standard, pretty uninteresting application of supervised learning. Uninteresting in the sense that any off-the-shelf algorithm is probably going to be somewhat useful here. So I saw a lot of creative needs for supervised learning approaches where you want to infer relationships between human actions and sound or visuals or some sort of other computer action, right? And of course here, We just want to have a data set which consists of some human example human actions paired with the thing that you want the computer to do or the label that you want the computer to apply, and so on. And then if everything goes well, you're going to have a model that's built that is capable of classifying or doing regression to give you the computer behavior that you want. Okay, so as I mentioned, when I started this work, there really weren't any tools that allowed people to do this in real time, and that connected well to the existing software that people were already using to do real-time music, for instance. So I built a piece of software called the Weckinator to try to make this easier. But really quickly, I learned that making supervised learning work for human creators required a lot more than just putting a friendly, graphical user interface on top of the machine learning workflows that people in more conventional domains would use. So that was a big surprise to me, and that was really the root of a lot of my research since then. So one thing, of course, that's quite different if you want to use machine learning to build a new instrument that responds to your gestures is that you probably don't have an off-the-shelf ground truth training set that you start with, right? There's not like the definitive hand gesture to sound data set that's like a benchmarking task. So the first thing that the Weckinator does when you use it is allows you to demonstrate examples for training in real time to say, here's some, one hand gesture and this is going to be sound 1, and here's another hand gesture and this is sound 2. And I'll show you a little demo of this in a minute. Then once you've built this model, this classifier perhaps, turns out it's not particularly useful for a human creator, instrument designer to get something back that says, oh, congratulations, your model has 95% cross-validation accuracy, right? What does that even mean, right? Can you use it in a meaningful performance? Who knows? So the next thing that Weckinator does that was very different to other tools at that time was allow people to test out the model in real time, right? Wave your hand around, see where it makes mistakes. If it's got 95% accuracy, are those 5% of mistakes on gestures that are really central to your idea of what the performance should look like? Or are they edge cases that you can learn to avoid as you move as a human? And then the third thing that Weckinator allows you to do very differently to tools of its time was to be able to go back and modify the training examples. So if you move your hand around and see that, it's doing the wrong thing when I do this particular variation of my gesture, actually it's, might help if you choose a different learning algorithm, if you add another layer to your neural network. But actually, before you start doing that, the sensible thing to do might actually be to go back to your training set and give it some examples of the thing that it's done wrong. Because maybe when you made that training set, it didn't occur to you to include examples of that type. So Weckinator allows you what's called an interactive or human-in-the-loop type of machine learning, where the human activity here involves not only tuning the algorithm and the algorithm parameters and maybe selections about features, but also changing the training set dynamically and very interactively, quickly, iteratively in the process of building a thing. Okay, so that's my introduction to Weckinator. I'm going to show you a bit of a demo. Normally I like to do live demos, but that doesn't work so well over Zoom, so I'll show you some videos. And then in the next part of my talk, I'm going to step back from this and reflect on what I've learned from all the people using Weckinator and similar tools that I've built over the last decade or so, and how that has changed the way that I think about machine learning and why it's useful to creators. So here we go. All right, in this demo, I'm going to build a very simple gesture-controlled drum machine using Weckinator. As my input device to capture information about gesture, I'm going to use my webcam. And I've got a little program here, which I like to call the world's worst computer vision feature extractor. What I'm doing is just taking those pixels coming in from the webcam and downsampling that to a 10 by 10 grid of color values. And this gives me 100 numbers, and these numbers are going to change as I move in front of the camera, as you see. But even if you're an amazing programmer, I would guess that you would not want the job of writing the program that looks at these 100 values and says something useful about what I am doing in front of the camera. So instead, we're going to use machine learning to make sense of these 100 values and make pretty accurate predictions about what kinds of gestures or motions I'm doing. All right, so I'm going to have Weckinator here listen to 100 values from this camera program, and I'm going to build a classifier, which is going to, again, predict what type of action am I doing at the moment. And we're not going to load a training set from somewhere else. We're actually going to build this training set right from scratch in the demo. And I want to, not just have Weckinator output a number. I want to have this control a sound and make this a little bit fun, right? We're going to control a drum machine, like I said. So I'm going to run a very simple drum machine program written in Chuck. And when I send this drum machine different numbers, we're going to hear different sounds, just like this. All right, so let's start out. Let's give it some training examples. And I'm going to say that when I am right here in front of the camera, I want to hear this simple sound. So I've got 17 snapshots of me here paired with this sound. And next I'm going to tell it that when I'm not in front of the camera, turn that down so you can hear. When I'm not in front of the camera, when I'm out of frame, I want to play a different sound, specifically this one. Let's go. Okay, now I've trained, I've built my model. Let's run this model and see what happens. Okay, it's pretty good. It's definitely changing between the two sounds, more or less the way I'd like it to. However, it's being a little bit too eager to change to that second sound, even when I'm not totally out of frame yet. So I'm going to give it some more training examples to try to fix that error and say that when I'm right here, actually I still want to hear the first sound. And now I'll retrain, I'll rebuild that model, and we'll see if it works any better. And in fact, that's pretty good. I can keep moving around and see if I can make other mistakes, like right here. I can, oops, forget I did that. Let's give this as sound 1 and say that I want sound 1 over here. And I can retrain and keep running and see that, yes, it's doing what I'd like. And once I'm happy with that, maybe I want to make it more complicated. I could give it another sound with, say, my hand in front of the camera, like this. Okay, there we go. That is a pretty easy way of using Weckinator to make a classifier where I'm controlling a few different sounds based on simple movements of my body. All right, so that demo I just showed you was pretty fun. You can imagine that for an audience, watching somebody move on the stage is probably more interesting than watching them just change sound by clicking a mouse button. And in the hands of a good choreographer, you can imagine something that becomes really visually compelling as well as sonically interesting. But when professional composers have used Weckinator, they're using it in a slightly different way, often to exploit the fact that you can use machine learning to build very different types of instruments. The sounds that you heard in the previous instrument were the same sounds that I could easily make by just pressing a few buttons to switch between different sound options. But sound becomes a lot more fun to many electronic composers when you can explore a really big space of sounds, when you've got a large palette to draw from and you can come up with ways of playing sound that are much more nuanced, much more complex, more exciting than just switching between a few different presets. So in this demo, I'm going to show you how you can use Weckinator with regression to do exactly that. And the instrument we're going to play is going to control a sound synthesis algorithm called Blotar. And Blotar is fun because it has a lot of different sounds that it's capable of making. So here's just a few of the Blotar sounds. Okay, and for each of these sounds, I'm getting that sound by giving Blotar a different set of control parameters. Specifically, I'm changing 9 of its control parameters. So you can think of each of those sounds as a point in a 9-dimensional space. And I'm going to build a blowchart instrument where I control these sounds using this. This is a game track controller from an old PlayStation game called Real World Golf, but we're just going to use it as essentially a 6-axis joystick. I get X, Y, and length of each of these two strings that I pull out of the base here. And so I'm going to tell Weckinator I want to take these 6 input values and use them to control those 9 blowchart parameters. And I'm going to use regression so I get smooth changes. And of course, this is, again, something that would be really hard to do even for someone who's an expert programmer, because not only are you trying to find good positions in this 9-dimensional space, but you're trying to come up with a mapping function that says how the motions that somebody's doing here move you through that space in a way that's not only musically interesting, but maybe gesturally comfortable, where the gestural mapping might be easy to learn or easy to execute certain gestures that give you sonic gestures, and so on. So that's very hard to think about as a programmer. It's a complex function to write, but here we can do it pretty easily with machine learning. So I'm going to start out by finding a sound that I want to put in the blowchart. And maybe I want that sound, and I'm just going to put it over here pretty comfortably. Record some examples, and maybe another sound higher in pitch, say over here. You can record some examples here, and just training from these, you understand what's going to start happening. Okay, so I've got smooth change, and it's learned that lower pitch is over here, higher pitch is over here. That's fine, not too interesting yet. Let's start to add more sounds in and see what happens. Put this sound over here. Should mention this is taking a little bit longer than usual to train because I'm running my video capture software at the same time. Okay, so hopefully you saw some interesting stuff happening there. Not only was it giving me access roughly to the sounds that I put in the training set, and still having this behavior that when my hand was kind of back here, I was getting a low to high pitch relationship, but it was also giving me all sorts of other sounds as I moved between these very, very different timbres, which I'd put in different parts of my gesture space. I was getting sounds that I didn't put in the training set that I have never heard before, even though I do this demo quite frequently. And this means that I can start gesturally exploring the space of this synthesis algorithm. And of course, I can use machine learning to refine this instrument or this mapping that I've created. If I like a sound somewhere, I say, oh, that's a really cool sound and I like it where it is. I can add more training examples of that pair to reinforce that behavior. Or if I don't like a sound somewhere, I say, oh, that's silly, that's silent, or that's just really stupid sounding. I can put a different sound in that part of the gesture space and retrain it, and I'll get a different instrument. And I can keep refining my instrument in this way until I'm happy with it. Then I can save the whole thing and run it, the models as they are during performance. Or perhaps I could even write a piece, and I've done this a few times in the past, where a performer retrains the instrument on stage, and the evolving relationship between sound and gestures is part of a piece. But most composers don't do that. Most composers spend a fair amount of time refining the instrument until it's something that they're happy with, and then they move on and do other aspects of the work.
All right, so that's the end of my demo. Thanks for watching that. Now, in the last part of my talk, I want to
discuss this as a researcher. So as I mentioned, I made the first version of Weckinator 12 years ago now. I completely rebuilt it about 5 years ago in response to a lot of feedback and teaching that I had done with creators in different domains. And since that rebuild, I've had something like 40,000 users in a lot of really interesting application areas. So I want to talk about what creators have done with this improved access to supervised learning, and to the extent that I understand why have they done these things. And what does this teach us about machine learning, about creators, and about making effective tools for creators? So the first high-level finding that I want to share is that, yeah, actually, unsurprisingly, enabling more people to use machine learning and supervised learning specifically can help them work with data more effectively, working with sensors and real-time data analysis from other sources. And people have done some really fun things. And I just want to show you a few of my highlights before I move on to the next, more technical bit. So here's one of the first pieces written with Weckinator. This is by a composer named Heggy, and this is using the same PlayStation Golf controller as in my second demo, but she's done really beautiful things with it. So here you go. I really love this piece. I also hope that it's clear to you that when Anne was making this piece, she had some very specific ideas about how she wanted people to be moving over time, and the way that that connected to the sound that was going to be happening as from the results of their movement. And of course, this is the sort of thing where even if you're an expert programmer trying to pick apart logically what data you would get from these sensors and try to translate that into some kind of control over sound becomes a really difficult problem. And that problem is even more complex in another favorite instrument, early instrument of mine. This is Martlet by Michelle Nagai. And this is a piece of tree bark where she embedded 25 light sensors into the tree bark and connected that to sound synthesis. So you play this instrument by moving your hands over the tree bark to cast shadows. And again, this is just an example of something where it would be very, very hard to build something that gives you musically expressive control with this kind of dimensionality of 25 light sensors controlling, a dozen or more sound synthesis parameters. But she was able to make something, I think, really lovely with it. People have been using Weckinator in all sorts of other domains, not just music. One of my favorite art projects is this one. You wear a camera on your head and some special glasses. Weckinator is used to classify whether or not there is a screen of any sort in your field of view. So if that's the case, your glasses turn opaque and you're not allowed to look at that screen. This is a nice project from one of my workshops. This is from a student at Carnegie Mellon who took a leap motion, which senses where your hand is in space, connected that to a little servo motor on an Arduino and some cardboard, and this is what it does. So this is Hybot. When you wave at it, it waves back at you. This is the sort of thing that you absolutely could build without machine learning, but it's a lot faster just to do this kind of interactive prototype by giving some examples of somebody waving rather than sitting down and saying, what data do I want from the leap, and how is that, how are those coordinates of the hand going to change over time in a legitimate wave as opposed to some other ancillary gesture. There's a lot of other examples online, everything from shoe-controlled instruments by Chicks on Speed to interactive puppet shows to technologies for people with disabilities and beyond. Okay, now let's talk about the machine learning bit a little bit. So one of the biggest surprises to me when I started doing this kind of work was that building interactions with machine learning in this way, especially creative interactions, often requires a different approach from the way you think about machine learning in many other applications. So I'm going to make a distinction here between conventional ML, the kind of thing that you'd normally learn about in a computer science course, and ML for building things like I've been talking about it. So conventionally, you're used to thinking about machine learning as having the goal of building the best model of data that you can in order to maybe make accurate predictions. So if you're using generative machine learning, you want to generate as believable outputs as you can, right? You're going to operationalize this term best somehow, but everything is sort of in this flavor. And then if you build a model, it doesn't do what you want. Generally, you're going to tweak the algorithm a bit, right? You might use a different activation function in your neural net, or you might use a different representation for your data. And data here, we're treating it usually as a ground truth, right? There's some hidden truth about the world that exists in our data, and we're using machine learning to get at that data because we might not have other tools to maybe logically represent that truth. Now, contrast this to the way that I've been using machine learning in Weckinator, the way I've been talking about it. So the goal for the creators that I've worked with, the people in the videos that you just saw, is often to build something. Maybe it's an accurate controller for a video game. Maybe it's a musically expressive instrument. Maybe it's something that's useful or fun, and so on. And that's a little bit amorphous compared to building a model that can make measurably accurate predictions or believable copies of something. Improving a model in Weckinator style interactive machine learning, in that case, yeah, you might want to change your algorithm, you might want to change your features or data representation, but it often makes a lot of sense, as you saw, to change what your model does by iteratively modifying the training data. And so again, when I talk about interactive machine learning, the way that that term is now used in human-computer interaction, this is a type of interactive machine learning. Really importantly here, the data, it's useful to think about data in a different way. Sure, it may contain some sort of hidden truth, but actually, in the hands of a creator, the data probably represents some explicit subjective decisions about design. The person has chosen the data they've chosen because it tells the computer something about what that person wants. So we can think about data as an interface for communication. And this requires rethinking not just the user interfaces that we plop on top of algorithms, but actually the choice and configuration of those algorithms as well. And so one of the consequences here is in Weckinator, I realized that, yeah, if we're going to build an interface, we should allow really easy iterative creation and curation of data, as well as hands-on experimentation with different variations of a data set. Also, when we allow this, when we say, okay, human, give us some data that starts to communicate your desires for a problem, and then maybe change that data as you go along, we have basically no reasonable hope of that data being IID, right? Which is an assumption that many machine learning algorithms make in order to make reasonable choices about how to model data, or it's an assumption that machine learning researchers often make when trying to think about how do we evaluate an algorithm, how might we improve an algorithm. But there's a really nice consequence of this. If you take some smart users who know something a priori about the application domain and an algorithm that I would say is capable of doing this, we could actually enable learning from very few strategically placed examples. All right, so this is the most machine learning bit of my talk. I'm going to get back out of this if this isn't your thing, but hang on for a few more slides if this is your thing. So let's say I want to build a gestural controller, and I've got two features, and maybe these are just where is my hand in XY space, and I want to learn a good decision boundary between two classes. Normally, the way we might think about a good data set for this problem in a machine learning class is we want really nice coverage of the green part of this zone and the purple part, right? If we had something like this, we would say, yeah, that's a decent data set. Of course, if we're going to do deep learning, hopefully we've got like at least a few hundred of these examples, if not thousands, right? We want lots of examples and nice coverage here. But if instead we're working with a person who's either generating this data by examples or maybe curating this data by saying, here's, I'm going to go to Google Images and give you an example, one image at a time, of green things and purple things, you might get a really small data set. to start with. And in fact, you might often get somebody giving you what they would consider to be sort of canonical examples, right? Not edge cases, not things that they think are hard, but things that they think are easy. And if you put this into an interactive machine learning context and you use a really simple algorithm, like say k nearest neighbor, you're often going to get some kind of reasonable decision boundary in the middle of that space. And you can give that to a person who plays around with it and says, okay, what does this classifier do when I try to give it new test examples? And maybe I give it an example somewhere where I know it should be purple, and it classifies that here as green. And likewise, I give it another example, which I know should be purple and should be green, and it classifies that one as purple, right? Here, I've found some examples where my model fails, and the easiest thing I can do is actually feed those back into the training set as examples of the correct classes. And then if I have an algorithm that's happy to learn from very small numbers of examples and maybe happy to do what we would normally call overfitting to our data, we actually have the ability to get a decision boundary that's very responsive to these sort of odd new examples that a human will throw at it. So what we're able to do potentially is learn the desired decision boundary much more quickly from many fewer examples than if we were, relying on IID data from some other source, right? So here, again, what we've got is a human that's interactively exploring what the algorithm is doing and providing corrective examples, and hopefully an interface and an algorithm that make it possible. And so this is actually what Weckinator was doing in that first example when I had the world's worst computer vision system, and I was doing different positions of myself in front of the camera. Weckinator was literally using a one nearest neighbor classifier, and I was able to build something with a very small number of examples. I can do that, if I'm just doing a demo for myself now, I can do this with a few dozen examples, and that's it. So we're way not anywhere near deep learning land, but we're actually able to do something that is quite impressive given the poor quality of the data coming in. Okay. Now let's step back out of machine learning details here. Another consequence of this style, this interactive interaction, is that when people are creating things, if you allow them to interactively manipulate the training data, or other aspects of the design problem for that matter, what you're often doing is not necessarily enabling someone to get to their goal faster. In a creative context, what you're actually enabling is often enabling people to try out alternative ideas. All right, so in any creative domain, whether that's building a musical instrument, whether that's making a new piece of visual art or dance, or even engineering in many engineering domains, design research has noted again and again that making lots of alternatives, exploring lots of different prototypes, exploring lots of different ideas through prototypes is really essential for people to be able to make something that they're happy with, that also satisfies the design requirements in the end, whatever those might be. So any kind of tool that allows people to explore more ideas in the same amount of time can be really useful in a creative design context. Now, in Weckinator, I was really surprised by how well Weckinator did this because, of course, none of the learning algorithms that I'm using there, things like neural nets, things like nearest neighbor, these were not designed to enable people to explore alternative ideas. But because we have the ability for these particular very non-deep algorithms, I'm talking about neural nets with one hidden layer, for instance, you have the ability to retrain them very, very quickly on even an average laptop, and the ability for people to make a very small change here to the training data and see that result immediately in a change to the model. This ended up supporting rapid prototyping very well. And of course, I assume that you're looking at some current research in the deep learning space that looks at, how we might do this with other types of algorithms that don't lend themselves particularly well to completely retraining on the data set, because maybe you need more data and you need a longer training time. But, this is a very exciting area of current research. Okay. Fourth point I want to make here is that when we are talking about creative systems in which people are either mimicking or responding to embodied human practices. We're talking about domains in which it's very hard for even expert programmers to capture human practices or actions in code, right? So if you think about how somebody paints a picture, how somebody plays a musical instrument, even if someone is an expert painter or a violinist and an expert programmer, and you ask them, okay, write a computer program that describes how you move over time, or write a computer program that describes whether a painting is good, or whether a particular musical passage is played with the right sort of dynamic arc, right? That's incredibly difficult, if not impossible. However, if you take a music lesson, or you've done painting lessons, you know that it's full of examples. People, a teacher showing you, well, try playing it this way, or listening to sounds, or looking at existing art and talking about how other people have done things, right? As humans, when we talk about these kinds of creative activities, we're often talking with each other in terms of examples. And when we think about machine learning, the affordances of machine learning and creative practice, for me and for the people I've worked with, that's actually maybe the number one, the most important thing, in that it allows us to communicate with computers in a way that is more natural, that's more similar to the way that we communicate with each other. And this was another very hard won lesson for me. This wasn't something that I thought about as a computer scientist getting into this space. But when I started asking Weckinator users, like, why are you using this? There's all sorts of downsides to machine learning, right? It can be really confusing. It can sometimes not do it all what you want it to do. Many of them were expert programmers already. And I said, why would you use machine learning instead of coding? And I got answers like this. I've never before been able to work with a musical interface that allowed me to really feel the music as I was playing it and developing it. The Weckinator allowed me to approach composing with electronics and the computer more in the way I might if I was writing a piece for cello, where I would actually sit down with a cello and try things out. And again, I want to emphasize, this has nothing specific really to do with Weckinator, and this should be relevant to a lot of the deep learning things that you're talking about in this class. If you think about the role that data plays and the things that people might be able to communicate more effectively with data than with code, or even with language or with mathematics or other tools. Fifth point I want to make is that designing with data can enable more people to become creators. And this is also a space that's certainly been explored by a lot of people in other research as well. A lot of generative models that have received popular attention are receiving attention because of this, right? They can often make it easier for novices to conform to a standard. So if you think about tools like Neural Doodle or some of the recent NVIDIA stuff that allows you to draw and have it filled in a realistic way, you can leverage really large data sets of paintings or of photos and make it easier for novices to do something that they couldn't otherwise. In the professional music space, we have things now like Isotope Neutron Track Assistant, which allows novices, sort of at-home recording studio enthusiasts, to apply mixing and mastering to tracks in a similar way to what a professional might do. And of course, we've had some really fun Google Doodles and Blob Opera, which was, I think, the most recent one that I saw, that allow you, even without knowing anything about music, to drag some stuff around on a screen and come up with something that sounds like Bach, or that sounds like opera or something else. And this is all great. I think this is really exciting, and there's a lot of important work to do here. But I also want to take this a step further and emphasize that there's also the possibility to not use machine learning to enforce conformity, but actually to allow more people to do personalization, to make more flexible interfaces, to make things for themselves and for others. And so one of my recent projects is called Sound Control. This was a collaboration with music teachers and therapists who have a bunch of kids that they work with on a daily basis who have all sorts of different disabilities, both physical disabilities and learning disabilities. And I made them a machine learning tool that's similar to Weckinator in many ways, in which they can make musical interfaces for kids, no matter what kind of music that kid wants to make, no matter how that kid can move comfortably. And of course, music teachers and therapists need to know a little bit about machine learning, the idea that you can give examples and build a working model from examples. They don't know any of the math. They're not programmers. They're not even really digital music people at all. But one of the most exciting outcomes from this project was not only did these music teachers and therapists start making bespoke instruments for kids, which is kind of the point of the project initially, but once they had the ability to make new physical interfaces for making sound, they ended up doing totally unexpected and useful other things. So they were making listening games, they were making improvisation games, they were making performance activities where they could play an acoustic instrument along with another kid, and so on. So this opened up a lot of really exciting things that we never would have gotten, certainly if they'd been limited to something like the Bach Google Doodle. And they were doing things that also they wouldn't have been able to do if it had just been like an engineer sitting with them saying, hey, tell me what kind of instrument you want to make, right? So thinking again as, data as an interface for people to communicate things, that's a very accessible interface where, people are musicians, they're going to probably find it easy to generate or curate musical examples. And that's the case for other domains and other types of machine learning as well. All right, the last point I want to make here is that machine learning, I've found very useful in the set of people I've worked with. It can provide productive surprises and challenges. And often in creative work, it's not necessarily the case that you always want the computer to just realize some vision that you have fully formed in your head. Whether you're using machine learning or not, often having creative tools that surprise you in some way or add some sort of unexpected ideas into your working process, these can be useful. And when people think about the creative potential of machine learning in human practice, I think this is something that comes up again and again, and people recognize the value of this. But even then, it's often really limited to the context of generative machine learning. This idea that, oh, if we can generate some new musical melodies, then maybe that'll be useful for musicians. Or maybe if we generate some new color palettes, that'll be useful for artists. And I don't dispute that that's the case, but I also want to encourage you to not overlook other types of machine learning or even other non-machine learning types of working with data. And I'm going to leave you here with a quote from a composer that I've worked with a lot over the last 7 years. This is Leticia Tsunami, and she's used Weckinator in her practice, again, for many years now. And when talking about why she uses machine learning, this is one of the things that she said. In a way, you don't want the instrument to perform like a well-trained animal circus. You kind of want it to be a little wild. You want to adapt to it somehow, like riding a bull. I think the machine learning allowed more of this fun of exploring instead of going, I have to have a result right away. This thing is going to do that, and leaving it at that. So again, I hope you saw in the demo that I showed you the fact that non-generative methods can allow you this sort of fun of exploring. When I do these demos, I get new sounds all the time that I haven't heard. I get new ideas for how movement might connect to sound. And that's one of the most rewarding things for me. So hopefully something to think about. Okay, I'll briefly end with just a couple slides here summarizing some of the things I'm working on right now in case you have questions about them. So I'm working a lot with some game designers and VR designers on making interactive machine learning tools that are well suited to people in those domains. Right now we have a tool up called InteractML for Unity. If you are interested in VR or game development, you can check that out. I'm working with folks at UAL to make a set of tools that's a web-based set of tools to explore how we might achieve this kind of playfulness, accessibility, exploration, and so on that we've seen with Weckinator. How can we expose those perhaps in working with generative and deep machine learning? And I've done a lot of work in the last few years thinking about how and what we should teach creative practitioners themselves about machine learning, because unsurprisingly, I think machine learning users in creative domains can benefit a lot from knowing something about the algorithms that they're interacting with, from knowing something about how to work with data. But these are often really different skills and sets of knowledge than what you would learn in a computer science class. And so I have an article kind of recently published about that. And at the end of the day, I think a lot of my work looks at how building things with data and machine learning can be, how it can be accessible to a lot of people and enable them to do things that they couldn't do before. And I think it's important to remember that this is really in contrast to what most people experience when they experience machine learning, right? Most people, when machine learning is used in their lives, it's somebody else using it on their data, extracting value from them, or worse. And I think it's interesting in this creative space to use creative applications as a set of maybe case studies or examples to explore how we can make people's other experiences with data and machine learning less disempowering, and to explore how we can give more people, not just computer scientists, a voice in shaping how machine learning is used and how it impacts their lives. So with that, I'd like to thank you very much for listening. And if we have time for a few questions, I'm happy to do some questions.
Thank you so much, Rebecca. It was really inspiring and great talk. If anyone has question, please go on.
I have a question. So, when it comes to like sounds compared to other media, I think it's more like what you listen to is like the truth itself, as opposed to like having hidden truth that we use like machine learning to find out. For example, in your demo video, I would say those sounds are really hard to represent with a different medium like words or visuals. You might have your own adjectives like to describe sounds. We say some sounds are dry, we say some sounds are wet, but those are like pretty subjective. I wonder like what kind of challenge that this nature of sound poses, different from like, for example, computer vision.
Yeah, I think there are some differences between sound and, say, image, as an easy example. I don't necessarily think that it's the case that there's less ground truth in sound, right? There's plenty of research in which sound in which that is the case, what I would call more conventional applications of machine learning that play by the same rules as the machine learning you would use in a machine learning class, right? If you think about the kind of research that people are doing in the music information retrieval community, or behind the scenes to build recommendation engines like Spotify, people are trying to build algorithms that can describe what genre a piece is, or predict whether somebody's going to enjoy listening to it or not. And I think that's where I started out in my research with music and machine learning. And they're absolutely, there are ground truths there. They're complicated because they're, like many other forms of media, they're very culturally embedded, and the context is important, and the way that we talk about things is often with a pretense that they're more cut and dry than they actually are. But at the end of the day, you can use pretty typical approaches there to sound and get really good results. Whereas I think the kind of work that I did with my demos with sound, put that in a context where you're doing gestural control of games, for instance, which I'm doing in the InteractML project, and it's the same kind of thing. You have the same kind of relationship to data as you do. So I don't think sound is necessarily different in that way. I think it's more about how people are using data, what people using data or applying machine learning understand about the problem domain, right? Whether they can articulate through examples the kind of goal for what they want to build, or maybe in other cases, maybe they're not qualified to do that and they have to go out and curate a giant training set from the world. So I hope that makes sense.
Thanks.
Cool. Any other questions or thoughts? I think it is very interesting how you put it in the context of data can be an interface to create things. We had some discussion in the previous sessions, for instance, the one with Philippe Isola and Alyosha Frost, where they were also talking about data plus direction, or Philippe was talking about how generative models can be thought of data plus plus, where you have these data, but also the functions. And I think that the way that you pose the ML and data in ML is also kind of reminds me of that similarity where we can explore things by using this type of data.
Mm-hmm.
And other thing that I think is very intriguing is, you know, we haven't talked about this in the class, but of course there is always this issue of human alignment with machines, and the idea of who should get to you know, define the objectives that we want. And of course, it should be human, and giving human this capability to be able to actually define what is the objective is one thing that I can obviously see in your work.
Definitely. And one other thing that maybe I'll leave folks with is, you know, the defining an objective, it's in itself, right? Often when we're doing machine learning, we want to be able to say, well, here's our objective function. And if we, you know, apply some kind of optimization algorithm, we're going to get to the right thing. And so much of, you know, the work that I talked about today, you know, it's impossible for somebody to say, well, here's exactly what I want to minimize or maximize. And so much of it is sort of, you know, an experimental process where somebody, you know, creates a data set, tries something out, and then uses the data to kind of steer the model in a direction that they want to go. And maybe they backtrack because they're also simultaneously learning about what goal it is that they're trying to address and how they want to solve it. And that may change over time. But actually this experiential aspect of, you know, I'm going to see what the model does, and I'm going to do trial and error, see how it responds when I do different things with the data, you know, that in itself is also a really powerful way for people to learn about machine learning in that specific context. And it's, you know, you're going to be learning things by doing in a way that might also be kind of hard to articulate. And there's some really interesting recent work by, I think, Carrie Kai and others in the pair group at Google, not looking at creative contexts at all, but looking at machine learning in medical contexts and how to help people reason about what machine learning models have learned and whether they're trustworthy and so on. And they've had some work in the past few years, I believe, looking at you know, how similar kinds of experimental exploratory processes linking people and models and data can help people, you know, build trust, help people understand what's being modeled, even when they don't necessarily have prior machine learning expertise. So I think that there's a lot there to think about in other sorts of human application domains where you want these kinds of, you know, productive relationships, useful and trusting and appropriate relationships between people who are maybe domain experts or using the things and trying to derive benefit, but aren't, you know, they're not computer scientists and they don't want to see a, you know, a graph at the end. They might want other things.
Excellent. That's very, very interesting and inspiring to many of us. And thanks for sharing us this. I should mention that Rebecca is actually from the real Cambridge in England. So thank you for, you know, I know that there's, because of the time difference, and you have been cooperating with me to making this happen. I really appreciate that.
Thank you, Ali. And I'm really sorry I'm going to miss Tom's talk. I'm sure it's going to be great. Nice to see you, Tom. I got to go feed my kid dinner.
Excellent, thank you. I think Tom is here.
Yeah, I see him on screen.
Okay, excellent. We should make him co-host. All right, thank you so much, Rebecca.
Thanks, everybody. Cheers.
Cheers, bye.